Hello and welcome to this new tutorial. Alright, so we have a final function to make in this part 1 building a blockchain, and that is the isChainValid function that will check if our blockchain is valid. So I remind that in this function we're going to check two things. First, we're going to check that the previous hash of each block is equal to the hash of its previous block, and the second thing we'll check is that the proof of each block is valid according to our proof of work problem that we defined in this proof of work function. Alright, so let's make this function. Again, this is going to be a method that we define starting with def. Then, as we said, the name of this function will be isChainValid, parenthesis, and which argument is it going to take? Well, of course, first self, and then obviously the chain. The chain because we're going to take that chain, iterate on each of the block of the chain, and make our two checks for each of these blocks. Alright, so the second argument is chain. Then colon, and here we go. Let's define this function. So, how are we going to do this? Well, of course, we're going to have to make a loop because we're going to iterate on all the blocks of the chain, and this loop is going to be a while loop. And when doing a while loop, we need to initialize the variables of the loop first. And the variable of the loop, which I like to call the looping variable, is the block index. So we'll need to initialize the block index. But then, since one of the check will be to check that the previous hash of a block is equal to the hash of the previous block, well, we'll also need to initialize a previous block variable. We'll initialize a previous block variable as the first block of the chain, which we'll get by taking the index 0 of the chain. And then you'll see at the end of the while loop, we will update the value of this previous block variable to be equal to the new block we are dealing with in the iteration of the loop. So we have to initialize two things. First, the previous block. So here, I'm just introducing a new variable. And as we said, we initialize this previous block as the first block of the chain, which we get by taking our chain and then the index 0 of this chain, because that way we get the first block of the chain. And then the second variable we initialize is, of course, the looping variable, which is the block index. I remind that each block has the index key in the dictionary, which is simply the number of the block, and the block's number starts at 1, so that the first block has index 1, the second block has index 2, etc. And therefore here, for our block index variable, well, we will initialize it to 1. And there we go. Now we're ready to start the while loop. So the while loop, you know how to do this. We start with while, and then you must ask yourself, what is going to be the condition? Well, we want to basically iterate on all the blocks of the blockchain, and therefore, since you also know that the looping variable is going to be block index, well, the while condition will be, of course, while our block index is lower than the length of the chain. Alright? We won't stop the loop until our block index has reached the final index of the chain, which is given by lenchain. Okay? So while block index, and then of course at the end of the while loop we will increment block index by 1 until it reaches the final index given by the length of the chain. So that's the condition. And now in the while loop, well, we're simply going to do our two checks, starting with the check that for each block, the previous hash is equal to the hash of the previous block, and then the second check, which will be to check that the proof of work is valid. So let's start with the first check. First, what we're going to do is get the current block. So I'm going to just call it block. Okay, and to get this current block, well, we take our chain and we take the current index of this current block we're dealing with right now in the loop. And of course, this current block index is block index, our looping variable. Okay, so that's our current block we're dealing with right now in the loop. So since block index equals 1 when we're starting this while loop, right now this block is simply the first block. And so now we're going to do our first check, and we're going to check that the previous hash of the block, this block we're dealing with right now, is equal to the hash of the previous block. And the way we're going to do this is with an if condition, and we're going to check that if the previous hash of the block we're dealing with right now. So here I'm taking the previous hash key of our current block. So if this previous hash of our block is different than the hash of our previous block, so I'm taking the self here because I'm using the hash method of our blockchain and not a separate hash function. So that's why we need to take the self, because hash is a method of our blockchain. So self.hash of the previous block. And so if the previous hash of our current block is different than the hash of its previous block, well, in that case, what happens? We have to return false, because that means that the chain is not valid. We need all the blocks to have their previous hash equal to the hash of the previous block. For all the blocks, no exception. And here, if we find an exception, well, we have to return false, because that would make our chain non-valid. Perfect. And now let's make the second check. The second check is to check that the proof of each block is valid. That is, if it solves this problem, giving a cryptographic hash of this operation starting with 4 leading zeros. All right, so that's exactly what we're going to check right now for each of the block. So how are we going to check that? Well, we're first going to take the previous proof, that is the proof of the previous block, which we have because we introduced this previous block variable at the beginning of our isChainValid function. So we're going to take the previous proof, then we're going to take the current proof by getting the proof key of our current block, and then we're going to compute the hash operation between the proof of the previous block and the proof of our current block, and we'll check if this hash operation starts with 4 leading zeros, and that will be enough to check that the proof of our current block is valid. So let's do this. Let's take first the previous proof, which is of course the proof of our previous block. So here we have to take our previous block first, which is a variable we introduced at the beginning of our isChainValid function, and that of course will be updated at the end of the while loop to be set equal to the current block, you'll see. So previous block, and now we're going to get the proof key of this previous block, which is, in quote, proof. All right, so that gives us the proof of the previous block. And then we need to get the proof of the current block. And to get this proof, well, we're going to call it simply proof. And then to get this proof, which is the proof of our current block, well, we'll take our current block. And then exactly as we did for our previous block, we're going to take the proof key, in quote, which is still proof. That gives us the proof of our current block. And now we're going to check that the operation between these two proofs, the previous proof that is the proof of the previous block and the proof that is the proof of our current block, starts with 4 leading zeros. So simply what we're going to do, and to be efficient, I'm going to copy this line, the hash operation we defined before to actually define the problem that the miners have to solve. Well, let's paste that here, and then let's not forget to replace new proof by proof, because we called the proof of our current block proof and not new proof. Then we can keep previous proof here because this is indeed the proof of the previous block, and then we keep the same because of course it has to be the same operation. All right, and that's it. So we have the hash operation between the proof of our current block and the proof of the previous block, and now we're ready to make our second check, which is to check that this hash operation starts with 4 leading zeros. And so how are we going to check that? Well, same, the idea is to check that with an if condition so that if we don't get what we want, we will return false, exactly as we did for the first check. And so if this hash operation has its first 4 characters, be careful here, different than the 4 leading zeros, well, if that's the case, we have to return false. Because of course, we want the first 4 characters of the hash operation to start with 4 leading zeros. So if we get this difference here, we have to return false. Perfect. And now we have 2 little things to do left. It's of course to update our loop variable block index and of course our previous block variable. So let's start with previous block. The previous block has to be updated the following way. At the next step of the loop, that is at the next iteration, the previous block has to become, well, the current block we're dealing right now at the current iteration. You understand why? It's because in the next iteration of the loop, the current block will become the next block of the chain, and therefore the previous block will become the current block of the chain. And that's why we have to update our previous block right now by setting it equal to block. Alright, so that's our first update. And then we need to update the looping variable, of course. And that's even more simple. We, of course, need to increment it by 1. Block index equals block index plus 1. And there we go. And so, now, the final touch of this function. Well, if we don't get any false anywhere, that is, if everything went well at the end of the loop, well, in that case, everything is alright, and therefore we return true. And that's it. Our chain is valid, and the isChainValid function is ready. And also, congratulations, because we are done with part 1, building the blockchain. So now we can move on to part 2, mining our blockchain. And you're going to see this is where it's going to get pretty exciting, because that's when we're going to start interacting with our blockchain, because basically we're going to start making the requests, to get requests to mine a block on the server or display the whole chain. So that's exactly what we'll do in part 2. We are ready to start. I can't wait. And until then, enjoy blockchains.